Hi there, I'm John from CNCKing.com, and today we'll be doing some prototyping for a thermoforming mold. Now what you see here is for thermoforming, and it's actually a negative mold. And the reason why we're making a negative mold is because we're doing prototyping with the customer regarding the actual mold. See, the problem that we have with molds is that we want something that lasts a very, very long time. A way to do that is to use either aluminum or to use a hard resin. Disadvantage with the resin is that it's incredibly expensive, same as the aluminum, but we have the MDF, which is relatively cheap, by comparison. So how do you make a very durable mold out of MDF? Well, the answer to that is pretty straightforward. You make a negative mold. So what would happen is the customer will, this is a prototype of course, it's a smaller scale just to double check things. So what the customer will do is when they get the negative mold, they're going to pour resin into this. And what the resin will do is it will go everywhere the MDF has been carved. And then what they do after that, they literally just flip it around once the resin cures in about a week. And they have their thermoforming mold made out of resin, but without the production and machining and tooling costs that would be involved with us actually making that mold here in the shop. Now the other thing to keep in mind with molds is that they can get very expensive, and if you're going to have any problems, especially when you have far larger molds, which we'll be doing in the very near future, you can have a perfect mold, has maybe 20 hours of machining time on it, and the last hour something might happen, power failure, whatever happens. The nice thing with the machine behind me here is that it's absolute. So even if everything gets shut down and everything just goes to hell, it still knows exactly where 000 is, so you just continue off where it left off. But sometimes, you get a broken bit, you get whatever, you can have some issues that you sort of have to contend with. And generally when you have problems will be in the last hour of a very, very long production job. So what I want to do is avoid that issue and produce scrap. So by using MDF, the only thing I would have scrapped was relatively cheap speaking MDF and machining time. If I was doing resin, not only am I going a lot slower, but I'm going into a material that's incredibly expensive to machine, and not just the resin itself, but also the specialized tooling that's required for that resin, because resin is incredibly hard, and the nice thing about MDF is it's basically glorified cardboard. So the biggest challenge that happens when you're making these kind of molds is actually trying to figure out the best bits to use. In this case here, I'm using a roughing bit, and it's clearing out all the stuff that I don't need into this mold before moving on to the next bit, which is the one that just makes a ton of sawdust. And what that one does is a very, very fine bit, and it's just making all the details that happen. Now, on both ends of the spectrum, I can use a thicker diameter bit, and I can use a smaller diameter bit. And the challenge is, I use a bigger bit to do the clearance, but then I give more work to the smaller bit to clear out the information or the wood that's in the mold. Because what happens is, the more of a space you have between the bits, the tougher it is on this bit here that you see doing all the fine work, because it might hit some parts that have a lot of material in them, and because of that it puts more stress on the bit, which might cause some other issues down the line. So again, it's just trying to figure out, do I use a 1-inch bit and then go down to a 1/2 inch, then to a 1/4 inch, and then to a 1/8, and then to a 1/16. You can endlessly do these kind of things, but all these things do affect the final production time. At the end of the day, the bit that takes the longest is this one you've seen happen right now, and that's the one I want to go as fast as possible, but it's also the one that if I have any problems, it's the first one that's going to break or shatter or whatever, or cause problems with the mold because it's such a fine resolution. Now, whenever we make custom thermoforming molds like this one here, if it's a new design or something that's a little bit more complicated, I like to do a prototype of it first and get the customer to review it and test it out at their end. And the reason for that is pretty straightforward. It's a lot more cost effective. If there's any sort of problems with this STL file or whatever can happen, it's easier to have it happen on something like this than something that's this big. It's just a whole no other magnitude of scale, just to make sure that everything fits perfectly into their production. And because these are basically just STL files, they can scale up or down infinitely. So, you know, if they needed, let's say 20 inches, and then the other one is 500 inches, and the other one's 2 inches, the model itself is identical all the way across. It's just the scale of it that changes. And that's the nice thing about sort of vector. It's not really a vector, but it's the same idea as a vector for the STL. So if you're looking for custom thermoforming molds, contact me at CNCKing.com. We can make it for you and ship it right to your door.